Thank you for introducing me, Dr. Lee, and hello, everyone. I'm honored to make a presentation in front of you who are conducting outstanding research in many fields today. However, please understand that I'm briefly introducing you because of my limited time. I'm currently a professor at Gyeongsang National University and the CEO of not WorkerInSpace. Okay. Before moving to university, I work at Korea for 23 years and also work at Hyundai Group. As you can see here, I'm going to talk about honorable servicing. Honorable servicing is literally providing service to sellers in space. The types of service include refueling, repair, replacement, relocation, and deorbit. With this honorable servicing, we can extend or guarantee the life of sellers. In other words, it's doing AS or maintenance in space. The need for honorable servicing is growing because the space environment becomes complex and dangerous as space development, including space debris, becomes active. Research on many of the high-level space technologies needed for honorable servicing began about 20 years ago, but actual commercial service only took place 5 years ago. As you can see here, the first ever commercial honorable servicing was launched in February 2020 by Northrop Grumman, initially on a 5-year contract and now on a 2-year extension. Currently, two satellites, MV1 and MV2, provide the service in space now. Since its first successful servicing in space, Northrop Grumman has been continuously developing technology. As you can see here, and is working to provide high-level services such as refueling and repair from simple track maintenance services. As you can see from the slide, the U.S. Department of Defense is also very interested and making direct investments on honorable service technology, and not only US, but also Japan, China, and Europe are developing honorable servicing technology now. Especially honorable servicing is directly related to national security in space. So why the DoD is interested in this field, especially refueling and maintenance in space? I'm confident that such honorable servicing will attract attention in the future space industry market. So when I worked at CARI, I first started researching related to it in Korea over 10 years. So based on my previous research experience in CARI, I started my own business after moving to university. Our company's vision is to grow into a leading company, not only in Korea, but also in the world. As you can see here, our company aims to develop a versatile robotic spacecraft based on humanoid technology that can provide various forms of orbital on-orbit servicing. In particular, it aims to develop smart robotic spacecraft through convergence of digital twin technology and artificial intelligence technology. As you can see here, our company's business model can be divided into three categories. The first one is honorary servicing. The second one is the service of production and assembly in space. And the last one is the disposal of large space debris. This is because the small or microspace debris is not interested in our business model. All of these business models are possible because they utilize common space technologies. I think you may already understand about the reusable launch vehicle. Likewise, it will change to a paradigm of reusing or reusable satellites in space in the near future, in space development and space operations. For that purpose, in the near future, satellites that can easily be refueled in space and satellites that can easily replace parts or components in space will be developed and launched. This paradigm shift is expected to lead the growth of the on-orbit servicing market on this track. In this slide, as you can see, our company plans to launch a demonstration satellite for technology verification in 2028. I can tell you that our company's technology development roadmap is a challenging plan that is rare even in the world. Currently, our company consists of a total of 22 employees, and it consists of satellite developers and robotic engineers. I think you may know Dr. Hong Baek, who was a director at president at CARI and director at ADD, is helping us a lot. Our company has many cooperative relationships at home and abroad. We have a relationship with KTSAT, who is operating up to 5 GEO satellites. And also we have a relationship and we have a MOU with ORBITPAM, who is developing the standardized the fuel tank to be easily to be repaired in space. What you see here is the appearance of the company's research institute. This institute is located in Sejong. Our research institute has created an environment where engineers can study creatively and independently. So everyone who are visiting us very surprised for our environment, like Google campus. So our company is the only private company in Korea to have a microgravity simulation test device. As you can see here, the microgravity simulation test device can simulate two satellites moving relative to each other on the ground environment as if they were in space. So finally, I will show you the scene of performing the test in our company's laboratory. As you can see on the screen, you can think of the customer client satellites on the left and servicing a robotic spacecraft on the right. We are using these test devices to develop four software for on-orbit servicing. And based on this technology, we aim to eventually manufacture a robotic spacecraft and then launch it into space and provide on-orbit servicing to customers' satellites. So I just introduce briefly because I just want to explain the many things during the Q&A time. Thanks for your listening. Thank you.